Here we go, lesson 10. We are finally starting trigonometry or trig. I'm not sure because of the whole shutdown last spring, depending on if you took geometry at Columbia versus here, you might have different experiences with some exposure to trig. Some of you may have had a little bit, some of you may not have had any. So we're really going to try to slow down and start from the very beginning, just assuming that we're starting from scratch. So if this feels repetitive to you, if you're like, bear with us because I'm just not quite sure and I want to make sure that you have a strong base. So we're going to start learning about trig, which is one of my favorites. Our learning target today, I can use trig functions to solve right triangles. That's kind of a broad one. That's actually something that we're going to be doing through several lessons. So our success criteria, I can use special right triangles to determine trig ratios geometrically. We will talk about what trig ratios are, what that means. I can use trig functions and Pythagorean theorem. So we'll do a little review of Pythagorean theorem to find missing side lengths of triangles. And I can identify and explain trig identities. So the first thing to know that these things that we are calling trig or trigonometric ratios only work if you have a right triangle. So here I have a right triangle, and I'm going to first talk about the labels. Typically, we're going to label our right angle C, although it doesn't have to be. And then I'm just going to call the other two sides A and B. When you are drawing these, it doesn't matter. Draw a triangle for every problem. Always draw a triangle. Draw a right triangle. It doesn't matter what it looks like. It doesn't matter if it's proportioned okay. It doesn't matter which direction it goes. Nothing matters except the fact that you get a right triangle on your paper and that you know how to label it. So the angles are capital letters. And then to label the sides, because we also need the sides, we'll talk about that in a bit. Okay, so SOHCAHTOA is a way for us to remember there are three major trig functions and then their reciprocal functions, so a function that goes with them. The three trig functions are sine, cosine, and tangent. So those are the three main trig functions: sine, cosine, and tangent. And all they are is starting from an angle, it's making a ratio or a fraction comparing two sides of a triangle. So it could compare these two sides or these two sides or these two sides. So it's always going to be a fraction with using two sides of the triangle. And how you determine which two sides is based on the function. Each of these functions uses different two sides. So sine uses an opposite side and the hypotenuse. And hopefully you remember what the hypotenuse is. Oops, if I can spell. And we just abbreviate it with an H for hypotenuse. Cosine is the adjacent side. We'll talk about in just a second what that means. And H is the hypotenuse. I'm going to show you how this all applies to the triangle in just a second. T stands for tangent. Tangent is the two sides, O, which is opposite, and A, which is adjacent. So SOHCAHTOA is just like an acronym to help you remember, like, oh, okay, cosine, ca, adjacent over hypotenuse. If you can't spell it, it's not going to work for you. So if you're going to try to refer to SOHCAHTOA, you got to know how to spell it. So is S-O, ka, and then toa. So I said that the sides are based off of an angle. So here we have an angle theta. This is a Greek variable that represents an angle. So let's say that theta is angle B right here. They could also just name it like sine of B. We could do that too. Okay, so let's say you are sitting at the lunch table, right? And we're at a triangular table over here. You are person B. we have three sides of a triangle that we need to identify: the opposite, the adjacent, and the hypotenuse. So maybe you remember that the hypotenuse is always the longest side of a right triangle, or it's the side that's across from the right angle. So this side over here is the hypotenuse. I have two sides left. One is the opposite, one is the adjacent. So if you're person B here, we're at this table, think about who's sitting opposite you, right? Who's opposite you at the table? It's this person over here. So this is the opposite side. And then adjacent means next to. You know, the people who live adjacent to you are your neighbors. They're next to you. So I have two sides that are next to me here, but this side's already the hypotenuse. I already named him. He's done. That leaves this side to be my adjacent side. So you're going to need to identify which angle you're using and then label your three sides: opposite, adjacent means next to, and the hypotenuse is the long side. So I am going to, just so that you have it nice and neat in your notes, you have SOHCAHTOA up here, but I'm also going to write the ratios down here. So the sine, so you can see them as a fraction. The sine is the length of the opposite side divided by hypotenuse. Please make sure that you know when you look at that, that is not a zero. That means opposite. So if you need to write out like OPP for opposite, write out a little bit more or put a note to yourself that that is not a zero. That is opposite. The cosine is a fraction of two sides. If they ask us to find the cosine, it's the length of the adjacent side divided by the length of the hypotenuse. And the tangent is the length of the opposite side divided by the length of the adjacent. And I will say that I actually have used this in life. When we bought our first house and I had to figure out the markings for our yard, or if you figure out angles and ramps and things like that, all uses trig. So we're going to use these to find sides of right triangles, angles of right triangles, all kinds of things. Okay, so those are the three major trig functions: sine, cosine, tangent. We also have then the reciprocal functions. So there are three main functions, three reciprocal. CSC stands for cosecant. I don't know. I should research where these names came from because I frankly don't know. Cosecant is the reciprocal of sine. Reciprocal, remember, means you flip a fraction. So sine is opposite over hypotenuse. Cosecant is the reciprocal. So you flip it and get hypotenuse over opposite. SEC stands for just secant. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. I know that these kind of seem backwards, like cosine and cosecant seem that they should go together. They don't. Like there's one S, one C. One S, one C. They like mix. It feels like they go backwards. And then COT is cotangent. This is the only one that's obvious which one it goes with. Cotangent is the reciprocal of tangent. So it is the length of the adjacent side divided by the hypotenuse. So let's show you how this actually works. I'm going to shrink my notes a little bit here so that you can see it all as we're doing this. So here's an example. And it's not really finding anything. It's just having us practice like identifying sides and setting up the ratios and things like that. So given the triangle shown, write the all meaning six of these, trig ratios for the given angle with measure theta. So I couldn't write the theta in there in my notes, but let's say this is theta down here. Actually, let's not. Let's do the other one just because that'll push us just a little bit. Okay. So first thing is draw your triangle. We got that. They already gave us that. Step 2 is to label each of your sides. So the labels always depend on your angle. Here's your angle up here. This theta, which is THE, theta. This theta is our angle. 29 is the hypotenuse regardless because it's the longest side, right? 29, 21, 20. 29 is the longest, so that's the hypotenuse. Now we need to decide adjacent and opposite. So here you are. You're at a triangular lunch table. Who's sitting opposite you? Opposite you is over here at the 21. So this is the opposite side. 20 is next to you. He's your neighbor. 20 is adjacent. So we're going to do sine of theta. And if you look back up here, sine is the length of the side opposite. Well, opposite was 21. Divided by the hypotenuse. How long is the hypotenuse? Hypotenuse is 29. So that is all we're doing for this problem, is setting up these ratios. The sine of theta is 21 over 29. Let's do cosine. The cosine of theta equals, so again, you look back up. I need to make it a little bigger. Look back up here. Cosine is the length of the side adjacent, so that's 20, divided by the hypotenuse. How long is the hypotenuse? 29. And then the last major one, tangent of theta. Look back up. Tangent is the opposite side divided by the adjacent side. So the opposite side is 21 divided by the adjacent side is 20. Okay, so there's the main three, but we got to do all six. So now we have to do their reciprocals. So cosecant, CSC of theta, don't leave the angle off or your whole problem is wrong because all of the sides are based off an angle. So without an angle, you have no trig, you have no opposite and adjacent. It is nothing. So please be careful you don't leave that off. Cosecant is the reciprocal of sine, so I'm just going to take the sine and do the reciprocal, 29 over 21. Or go back and look, it is the hypotenuse, 29, divided by opposite, 21. Secant, if we look back up, secant is hypotenuse, 29, divided by adjacent is 20. And then the sixth one, cotangent of the angle is equal to, cotangent is the adjacent side, 20, divided by the opposite side, 21. So we have now gone through and identified all six. So that's what trig functions look like. What we're working towards is sometimes there'll be, like in the next examples, there'll be a side missing. So we maybe have to find a side first, or we're going to have to, maybe we only have one side in an angle. We're going to use trig to find missing sides. We'll use trig to find missing angles, all of that over the next few lessons. So example 2, we are only asked to find one trig function. However, we don't have all three sides. So maybe I have the two sides I need, maybe not. Tangent of theta. So tangent, if you look back up at the top, tangent is TOA, opposite over adjacent. And it's based on my angle right here. So from this angle, the side opposite is this one. Oh shoot, I'm missing that. The adjacent is the 9. So I have the 9. I do not have this side over here. But I do have a right triangle, and I know two of the sides. So if I have a right triangle, and I have two of the sides, then I can find the third side by using Pythagorean theorem, which has probably been a while, right? Pythagorean theorem, let's put it up here. Pythagorean theorem is a squared plus b squared equals c squared. And the two sides don't matter. A and B are the two legs. Doesn't matter which is which. C is the hypotenuse. C is the longest one. So We're going to call this x squared plus 9 squared. Those are the two legs. Those are A and B equals the hypotenuse squared. The hypotenuse is 12 squared. So we have to solve this to find our side. 9 squared is 81. 12 squared is 144. If I subtract 81 from both sides, x squared equals 63. And then we need to take the square root of both sides. So the square root of x squared, the square root of 63. And I am not sure, but I think in delta, it makes you simplify this. So you can't leave it as 63. You can't leave it as a decimal. You would have to write it, you'd have to simplify the radical. So if I do a factor tree or a birthday cake or whatever it is, I get 3 root 7. So this side is 3 square root 7. Okay, so finally, I have my two sides. Tangent is the opposite, 3 square root 7, divided by the adjacent. The adjacent is 9. But look, we can simplify again. It's still not simplified. Delta makes you simplify everything. We need to reduce that fraction. That 3 over 9 reduces to 1/3. So it's 1 root 7 over 3. You want to try this one? You should pause me and try this one. Okay, ready? Here's my angle theta. Cosecant is the reciprocal of sine. If you look back up at the top, so it's hypotenuse over opposite. So my opposite's over here, which I'm missing again. Hypotenuse is 13. So I got to find that missing side using Pythagorean theorem again. X squared plus 12 squared equals hypotenuse squared. Oops, 160. So if I subtract 144, I get x squared equals 25, which means x is 5. So at least we don't have to simplify a radical this time. Now that you have all three sides, the cosecant is the length of the hypotenuse. So the length of the hypotenuse is 13 divided by the length of the opposite side is 5. So sometimes there's a lot more work with the simplifying. Sometimes they're fairly straightforward. All right, we have a couple examples left. More of the same, just different ways of doing it. Okay, so this one is the same problem, except that I didn't give you a drawing. I gave you all the information, and you have to set up the drawing. So remember that step 1 was a triangle, and you already had it in the first few examples because I gave it to you, but now you don't. So it says in each triangle, angle C is the right angle. So there's C down here. Find the value of the trig function indicated. So the right angle C, I can pick what I want for A and B. It doesn't matter. Capital letters are the sides. I don't think I said that up above. Capital letters refer to angles. I think I just said sides. Capital letters are angles. Lowercase letters are sides. And the sides are across from the angle. So if this is angle A, the side that angle would control or would affect is this one across from it. So this is side A over here. If this is angle C, the side that it would impact is over here. So this is side C. It's so hard to do this without like using my hands to show you guys stuff. And then if this is angle B, side B is across from it. So angles are capital, Sides are lowercase. If you need notes to yourself over here, right? Put it notes. Angles are capital. Sides are lowercase. And they go across from each other. So if this is angle B, the side B is across from it. So let's label our stuff here. We're trying to find sine of A. So this is my angle that I care about, right? Last time we used a theta inside, but I told you could use the letter too. If side A is 4 and side C is 6. So sine of angle A. And if you either think about the word SOHCAHTOA, not a word, but the acronym, or scroll back up, sine is the opposite side divided by the hypotenuse. Well, for once, we already have the opposite side. Opposite is 4, hypotenuse is C. We already have the two sides we need, so we have no reason to use Pythagorean theorem to find the missing one. Opposite is 4, hypotenuse is 6. We could reduce it and get 2/3. If you're up for trying one, go for it. If you're not, just stick with me. Keep playing. Whoop. Okay, so right triangle. Don't care which direction it goes. Don't care anything. Just going to label it exactly the same as this one. Here's C, A, and B. Okay, so here's my angle that I care about. This is where I decide which is the opposite, and the adjacent is based off the angle. Side B is 35. Side B is over there. And side C, which is across from angle C, is 37. Secant, I'm trying to find secant of angle B. So scroll back up. Secant is the reciprocal of cosine. Cosine is cot, adjacent over hypotenuse. So secant's hypotenuse over adjacent. So we have the hypotenuse over, I do not have adjacent. This is the adjacent side right here, and I don't have that. That means, unfortunately, we need to do Pythagorean theorem. So x squared plus 35 squared equals hypotenuse squared. I'm going to square these and subtract at one time. So 37 squared minus 35 squared is 144. And then to solve for x, we take the square root of both sides, and we get x is 12. So at least it came out to be a whole number. We didn't have to simplify a radical. So the adjacent side is 12. 37 over 12 does not reduce, so final answer. Okay. The last example, example 4. Example 4 is very similar to this. There's just one little spin in that I gave you the same information, just in another different way yet again. So I'm going to draw a right triangle because we always draw a right triangle to start. I don't have any lengths of sides. I mean, I don't have any labeled sides, but I do know that I need to base it off an angle theta. So pick which angle you want to use. It can't be the right angle. This one's already labeled. Don't use it. You got to pick one of the other two that don't have anything yet. So let's say this angle over here is my theta, okay? Because the angle determines everything. So scroll back up. What is cosecant? Which two sides is cosecant? Cosecant is the hypotenuse divided by the opposite side. So the hypotenuse is 13, and the opposite side is 12. We only have two sides. We got to use Pythagorean theorem to find this side, unless you remember that we already did this problem. We already had one where the hypotenuse was 13, and we had a missing side was 12. The other side was 5. So we could just steal that and not redo the whole thing. So once we have those sides, it says find the 5 remaining. Remember our very first problem was to find all 6 of them? You're just doing that now, except you got to find the other 5. So we're going to go through sine. Sine is, should we label these? Here's our angle, right? So 13 is hypotenuse, 12 is opposite, and 15 is adjacent. If you have trouble labeling those, make sure you grab me in class. So sine is for SOHCAHTOA. So it's opposite is 12 over hypotenuse is 13. Cosine of the angle. Cosine is adjacent over hypotenuse. So 5 is the adjacent over 13 is hypotenuse. Tangent of theta, TOA, opposite over adjacent. So 12 over 5. And then we need to do the 3 reciprocal functions. I already have cosine, or cosecant, excuse me. I already have cosecant, but I need secant, which is the reciprocal of cosine, so 13 over 5. And cotangent. Cotangent is the opposite or reciprocal of tangent, so it's 5 over 12. These notes are getting long. Again, it would be a good one to pause me right here. Try it on your own. Okay, so one last one. Let's draw my triangle this way, because it doesn't matter. There's my right angle. You need to pick an angle to be theta. Pick wherever you want. Let's do this bottom one. And let's label our sides. So if this is my angle, this is the hypotenuse. Sitting across from me is opposite. And my neighbor over here right next to me is adjacent. Right? Tangent, TOA, opposite over adjacent. That means that 4 is the opposite side, 3 is the adjacent side. So 4 is opposite, 3 is adjacent. We need hypotenuse, so we have to do Pythagorean theorem. But this time, we know the 2 sides, the 2 legs. I don't know the hypotenuse. So 3 squared plus 4 squared equals c squared. So if we take the square root of both sides, c is 5. If you didn't pause it now, you could try to do the other 5. We're going to do all 5 now. So sine is so opposite over hypotenuse, so 4 over 5. Cosine, so cosine's which is adjacent, adjacent over hypotenuse, 3 over 5. Tangent we already did, or we were given. And then we have to do the 3 reciprocals. So cosecant, remember that they go like a C and an S have to be together, so cosecant is the opposite of sine. Cosecant is the reciprocal of sine, so 5 over 4. Secant is the reciprocal of cosine, so 5 over 3. And cotangent is the reciprocal of tangent, so 3 over 4. If you don't like just doing the reciprocals, then scroll back up to the beginning where we wrote them all down, and you could do, okay, well, secant is hypotenuse over opposite, and you could do hypotenuse is 5, opposite's 4. So you can do it that way too if you don't like thinking about